Hello and welcome to Bit Gardener's Office Hours. My name is John Kowalski. I'm part of the marketing team here at Bit Gardener, and I'd like to welcome you. Today's topic is about gloss theory and applications. If you're unfamiliar with our office hours format, let me tell you about it here. It's a shortened presentation, maybe 20-25 minutes, followed by open discussion, your questions, any challenges you're having at your own facilities. We have some experts around on the phone here willing to help you out. So if you do have a question, please log it in the chat box located in the bottom right-hand corner of your screen, and we'll get to them in order. We are also recording this, including the discussion. So immediately following the presentation, you'll receive an automated email from marketing, which will contain a link to this webinar. So you can take a listen, take a look at it later, pass it to colleagues, whatever makes sense and whatever will help you in your gloss applications. So with that, let me welcome our senior application specialist and all-round color gloss expert, Mr. Corey Cohen. He'll be presenting. So there you go, Corey. Take it away, sir. And don't forget to unmute your mic.
There we go, unmuted. Thank you, John. Welcome, everybody. Looks like a pretty small group today, so I hope you came with lots and lots of questions, but who knows, maybe I'll answer them all before we get to the Q&A. So let's go ahead and get started. Okay, so when light hits a surface, directional light, there are a few things that are going on here. One is that, let me get my pointer started so I can point at things. There we go. Hopefully you can all see my pointer. So when the instant light hits the surface, some of that light is going to enter the surface, interact with the pigment. There's going to be some absorption going on. And that light that's interacted with the pigments, that's going to be colored. So the pigments are going to absorb certain wavelengths of light, reflect others, and then that light that is interacted with the pigments is reflected diffusely. So this diffuse reflection, this is all that light that's been modified by the pigmentation in this material. Now this reflection right here, this sort of rainbow reflection, is what we call the specular reflection or the gloss reflection, and that's just the opposite angle to the incident light source. And the reason it is showing up as this rainbow arrow, just like the incident light, is that this specularly reflected light has not interacted with those pigments. It's just bouncing right off that surface. And so that's the gloss angle. That's where we measure gloss. And as an observer, if you're standing at this gloss angle, the specular angle, what you're seeing is glare. You're going to see a reflection of the light source off of the surface. So how is gloss perceived? Again, we have a very similar setup. We have a light source sending light at the surface from a specified angle. And then we have the observer positioned at the opposite angle off the normal. So this angle and this angle are the same. This is the specular angle. This is where an observer would be positioned if they wanted to view the gloss reflection or the light source reflection. So here we have an observer observing this surface, and now we're looking at a very glossy surface. And so this observer is going to see a very crisp, clear reflection of that light source off of the surface. But now we have a rough surface, and so we're going to get less specular reflection and more diffuse reflection. And so that's going to cause the image, that reflected image of the light source, to be fuzzier and less distinct. And so non-glossy surfaces, low glossy surfaces, we refer to those as matte surfaces, M-A-T-T-E. So this is the design of a gloss meter. Of course, we have our light source at a specified angle, and then our detector at the opposite angle, the specular angle, because we only want, when we're measuring gloss, we only want to pick up that specular reflection, not the diffuse reflection. And of course, there are specified angles, how big the aperture lens is supposed to be, how big the light source lens is supposed to be, all those things. So it's specified in certain international test methods. So there are three international standard gloss geometries or defined angles of illumination. Those are 20, 60, and 85. So these are the three angles gloss is typically measured at. One is for low gloss surfaces, one is for medium gloss surfaces, and one is for high gloss surfaces. That's why we have three different angles. They're meant for different levels of gloss. And as you can see, that each light source at each specified angle has its corresponding detector at the specular angle. So this is always a handy little graph that I like to show. So what we have here on the horizontal axis, these are 13 gloss panels of increasing steps. And we're going to say that those steps are visually equal to each other. So visually, the gloss difference between, say, the 11 and the 12 is visually the same as the gloss difference between the 7 and the 8. So these are stepping up as we increase the number. The gloss is stepping up in equal visual increments. Then we have measured gloss on the side, the actual measured gloss in gloss units. That's the standard unit for gloss measurement. For each of these three measurement angles. All right, so first of all, you can see that we're getting widely different answers depending on which gloss angle we're using. So that's one thing to understand. You're always going to get different answers when you use different gloss geometries. All right, and what that means is that you cannot compare measurements from different gloss geometries with each other. So if I'm taking my readings with a 60 and you're taking your readings with a 20, we cannot compare those values because they're just not going to match up in any effective way. The other thing is that, so we can see here why we have different gloss angles for different gloss levels by the shapes of these curves. So let's say I want to know the difference between the 7 and the 8 panel here. So 7 reads, with our 60-degree meter, it's going to read at about, let's say, 39. The 8 is going to read at about 55. So what's that, 16 gloss units difference? All right, so between these two consecutive panels, 7 and 8, the 60-degree is seeing a gloss difference of 16 gloss units. But if we switch to the 20, we're seeing maybe 8 gloss units and 13 gloss units. So we're looking at maybe a 5 gloss unit difference. So it's not as big with the 20. It's not giving us as clear a differentiation between these two gloss levels. And similarly for the 85, the gloss difference will be much less for the 85 than for the 60. And that's because in this semi-gloss range, this medium gloss range, that's the optimal range for this 60-degree gloss geometry. We can see that the measurement curve is nice and steep and even. And then once we get into the low gloss range, that curve flattens out. And we see that the 85-degree curve is nice and steep and even. So again, let's take an example. Maybe we want to measure the difference between the 2 and the 3. Well, with an 85-degree meter, that's maybe 16 and 30. So that's a 14 gloss unit difference here. But again, we'll measure with the 60 now, and we see we're really only getting like a 2 gloss unit difference. So in this range, the 85-degree meter is best because we get that nice, steep, even slope, and we're going to get clear readings that give us clear differences between these panels that are visually different. And of course, in the high gloss range, that's with a 20-degree, the specialist for high gloss surfaces. That's where the curve is nice and steep and even. And for the 60 and the 85, it's flattened out somewhat. So that is why we have 3 different gloss geometries that we use, 3 different geometries that we recommend. This is the convention that we use for when to recommend which geometry. We say that if you measure your surface with a 60-degree meter, because remember, you're going to get different answers, make sure you're measuring with a 60-degree meter. If the value is between 10 and 70, we would say the 60 degree is the correct geometry. If it's greater than 70, we would say switch to the high gloss meter, the 20-degree geometry. And if it's less than 10 units, we would say go to the low gloss geometry, the 85-degree. So this is kind of a rough convention. This is not hard and fast. It's not that 60-degree readings are invalid the second you get above 70 or below 10. Many people do use 60 above 70 and below 10 because that is the sort of oldest geometry, the most widely used worldwide. So this is just kind of a general rough recommendation. Okay, so the gloss unit scale. So basically the way this was determined was when the first gloss meter was being developed, the engineers who did that said that this black glass that we have, this highly polished black glass with this specific refractive index is equal to 100 gloss units. So every gloss reading is relative to that reading of that black glass standard being 100 gloss units. So in general, the gloss unit scale goes from about 0 to 100. That's not the maximum end of the scale by far, but most materials, most paints, most plastics are going to read at about 100 or less. Sometimes you might see in the 100 single digits or teens, but really it stays below a certain amount for most materials, and that's because there's a significant amount of absorption for paints and plastics. No matter how glossy the surface is, that surface is always going to absorb some of that light, and so it sort of limits the maximum gloss level. Now, the gloss reading itself is actually dependent on the refractive index of the material. Index of refraction, that's just, it's a term for how fast light moves through a material. And so different glasses, different transparent materials can have different ratings. And since that one specific black glass with that index of refraction of 1.567 is very, very difficult to find, there's sort of an index of what different refractive indices will read with different angles, gloss angles. And so the point is that gloss measurement is dependent on index of refraction. So you can have two materials like this black glass that look the same visually, but if they have a different index of refraction, they are going to measure slightly different. And so the point is you really only want to compare gloss readings on materials with the same index of refraction. So here we have a 1K coating and a 2K coating. They're going to have different indices of refraction, and so they're going to get different gloss measurements, even though the visual brilliance is the same. So we do have our micro gloss meters for measuring gloss, and we do have 1 meter, the micro trigloss, that can measure all 3 standard angles in one, always in compliance with international standards. You can select 1, 2, or 3 angles to display, and these micro gloss meters have this expanded measurement range that goes up to 2,000 units. So you might be asking, why do we need a meter that goes up to 2,000 units if everything measures at 100 or less? Well, not everything. I'm gonna skip past this real quick. Not everything does measure at 100 or less, and the exception is metals. Metals have near total reflection of light. They don't absorb a bunch of the light like most other materials, paints and plastics things do. They're going to reflect pretty much all of the light that you shine on them. And so the gloss levels of a metal surface can get much, much, much higher than your typical planes and plastics. So the maximum scale, it depends on the geometry, but the maximum scale for the 20 degree, the high gloss geometry, is actually 2,000 gloss units. For 60, it's 1,000, and for 85 degrees, it's 160. So if you're measuring metals, metals typically measure up into the few hundred gloss units range. You do need a meter with this expanded measurement level. Now, another way that gloss meters can output these readings is in percent reflectance. So I'd say that gloss units is far more commonly used, but you can get the reading in just percent reflectance, and that is often used for measuring metals. And the way you convert back and forth is you just take the maximum scale for the angle you're using and divide the gloss reading into that. So, for example, for the 60 degree meter, the maximum scale is 1,000 gloss units. So if you have a reading of 100 gloss units, that's 10% of the maximum scale. And so we would say it's the reading is 10% reflectance. Oh, I do want to go back to this. Okay, so here we have a couple of panels that are being weathered. This is a weathering test. So it's being stuck either outside or in some weathering chamber, some QLab weathering chamber or whatever, for a certain number of hours, and they want to see how well the gloss is holding up over that time. And so you can see that we have two panels, panel A and panel B, and each panel is being measured with both the 20 and 60 degree geometry. And we can see here that for panel A and panel B, for the 60 degree reading, they're pretty much right on top of each other at the start. They're the same after 100 hours. They're the same after 200 hours. It's really only after 250 hours or so that we're seeing any difference in those 60 degree readings. Now, note that where we start off, we're at about 90 gloss units. So according to our recommendation for when to use which gloss geometry, we would say this is when you would want to use the 20 degree geometry. And so if we look at these 20 degree readings, we can see that there actually is some differentiation between these two panels right at the start and ongoing. Panel B starts out glossier than panel A according to the 20 degree reading, and then dips below it. So we would say that the performance for panel B is much worse than for panel A, whereas for the 60 degree readings, we can't tell as much of a difference. So this is why we want to use the 20 degree in that high gloss range, but also note that at the start of the test, the reading is about 90 gloss units with that 60 degree meter, and at the end of the test for panel B, it's dipped below 70. So this is why it's good often to take readings with multiple geometries. We really do recommend that micro tri-gloss meter, partly because it's really not that much more expensive relative to a single angle meter. And so if you have any possibility you might need more than one angle in the future, it really is worth getting the micro tri-gloss right off the bat. Okay, just a couple more applications. So one is on curved surfaces. So because of the directionality of the measurement and how important that is, it's really best to measure gloss on flat surfaces, but of course we know that that doesn't always work out the way we want to in real life, and sometimes we do need to take readings on curved surfaces. So you can see here that light that we're seeing here, rather than being all sort of reflected parallel to each other, because there is some curvature on this side, that light, think of it as like a lens, it's going to sort of disperse that light. And so on this curved surface, less of that light is going to reach the detector. So just know that readings on curved surfaces are typically going to be lower than on flat surfaces, even when you're comparing the same material. Another consideration is that you want the meter to be as tangential as possible to surface. You want it to be as flat as possible to get the best reading possible, because if the meter is tilted a bit, you're not going to get a good reading. Even more, that light is going to bounce away from the detector, and you just won't get any sort of good comparable reading. So you really need to make sure that the meter is positioned correctly on your curved surface. And for this, we either recommend creating some sort of jig, something that your piece, whatever you're measuring, can fit into, so that the meter is positioned the same way every time, or there is a continuous mode that I like to use when measuring curved surfaces like this. And what I would do is you can set it in continuous mode to automatically take a reading every second, and just sort of slowly roll it across the surface to make sure you're getting that, at least one of those continuous readings will be a good one. And then when you stop it, you can look up the maximum for the best value. So I'm not sure that quite made sense to everyone, but if you do need to measure curved surfaces and you'd like to speak about the best way to do that, you can certainly reach out to me. Transparent surfaces. So these are always trouble, partly because, as you can see, with any transparent surface, anytime you shine light on it, you're going to get some reflection off of the top surface and off of the bottom. And of course, the light, much of that light that hits off the bottom, some of it is going to go through these interreflections, and so it's going to not make its way back to the sensor. Some of it will bounce, even if it does come out, it's going to bounce away from the sensor. So again, on transparent materials, we do expect the gloss reading to be a little lower. Particularly, it's very important to control for the thickness when measuring transparent materials, because the distance between the top of that material and the background, the backing, whatever's beneath it, is important. That's going to affect the geometries of the measurement. And so you really only want to compare measurements of transparent materials that are the same thickness. And now the background or backing is another consideration. You need something opaque, something solid to take your measurements against. And for that, we recommend a black matte material. We want to have the most non-reflecting material possible, because we want any reflection that any light that's getting into the detector to be gloss that's reflecting off of the material you're actually testing and not off of the backing. So you want that backing to be very dark, black if possible. You want it to be very low gloss. I often recommend flooring, like tile, tends to be very color consistent. So if you can find like a very dark colored matte flooring tile, that should work as a good backing. And that's it. Time for some questions.
Sir, appreciate that. Got one question in here from Jack. For the micro trigloss, do we have apertures to measure smaller surfaces, or what are the aperture options?
So each measurement angle has its own spot size, and I can show those to you. Hold on. Okay. Now I need to share my screen. Very good. And okay. So hopefully everyone can see this page from our catalog. The measurement area is in there. So for the 20 degree, it's 10 by 10. So 1 centimeter square is required. For the 60 degree, it's 9 by 15. And for 85 degrees, it's 5 by 38 millimeters. So for all three at once, you would technically need a 10 by 38 millimeter spot. We do have one meter, well, with the exception of the 45 and the 75, those are special angles for certain specific industries. 75 is for like paper and paperboard, and 45 is for, I believe, plastics and laminates and things like that. Oh, it says right there. Yeah. Anyway, so aside from these three standard options, we also have the XS model, which has a spot size of 2 by 4 millimeters. So this is our small aperture model. See if I can find the picture. There it is. So you can see that little aperture there in comparison with a match. So it really is very small. And so this is what we recommend for small parts as well as parts with high curvature. Measuring with a smaller aperture can sort of mitigate some of the difficulties of measuring highly curved surfaces.
Great, thank you, Corey. Jack, hope that answered your question there. If other people have questions, please log them in the chat area and we'll get to them. We have lots of time left to help you out in any way we can. Just from when you were talking, Corey, just about the jig for curved surfaces and also the matte backing or the dark black matte backing for transparency, a lot of it is just getting a consistent process down and doing everything the exact same way from first shift to second shift to third shift. You know, that's half the battle there, isn't it?
Yeah, I mean, really, consistency is the name of the game for any sort of measurements, particularly optical measurements like this, where there are just so many things to control for, so many little variables that can throw off your readings and make it so you're not getting, you know, a good evaluation of your product. So yeah, keep things consistent. If you take away one thing, it's keep things consistent. Trying to think of anything. Can't compare gloss angles, get a backing for transparent materials.
That floor tile is a good idea that you mentioned.
The other thing for the floor tiles is you want to buy like the whole case, because if you buy a case later, it could be different. So you want like all of those to be the same in case you break one.
Yeah, that's a good point. That's Ray Roby, folks, our business line manager for automotive. So thanks for joining us, Ray.
Thank you.
You bet. You're always welcome. So Corey, Ray, or any of the other BIC personnel on, are there frequent questions when you get into gloss applications that you constantly run into that we can shed some light on?
Thing is huge, and the making your own, you know, holder that's going to make it always the same is huge. I mean, like I've seen it in automotive tons of times, like where people they're like, oh, the measurement's not consistent, and it's not necessarily the measurement, it's how they measure. Or if you do like what Corey said, which he would be more than happy to explain to you, the multiple measurements, and then you take the average, or you don't take the average and you just use all that data to try to figure out the actual gloss measurement is also important.
For what types of applications would you use the multiple angles and measurements and then average them?
So from my perspective, mirror housings can be a problem, different appliques, but Corey probably knows more because he's got more background than I do with different applications.
As far as taking, so you were saying take it and take the measurements from multiple, with the meter in multiple positions. Is that what you were saying, Ray?
I only know like mirror housings and appliques, you know, like small parts. But for you, you probably know way more about different applications than I do.
Yeah, the XS, the small aperture one, has really come in handy a bunch of times. There are a lot of things that we wouldn't be able to measure with the full aperture model, and I was able to get with the small aperture. And what I do is, well, let me share my screen again. So yeah, I find it easier, and I do this with color meters too, with spectrophotometers. If the part I'm measuring isn't much bigger than the aperture opening, I find it easier to just turn the meter upside down and just lay whatever I'm measuring on top of it, rather than trying to place the meter on top of a very small object and center it perfectly. So it can be helpful to position it like this, upside down, and just measure your part right up against the aperture. The orientation of the meter, whether it's upside down or not, it's not going to affect the readings.
Cool.
I've also seen that works at a lot of places because you can actually get the part more onto the aperture if you turn it upside down. And like he said, the meter doesn't care.
Good.
But you have to remember this small meter is only 60 gloss. And sometimes we forget to say that. So
yeah,
Gotcha.
Yeah, that is right.
Another question here. Can I measure gloss and color together or at the same time?
Well, yes, we have solid colored spectrophotometers, handheld spectros with 60-degree gloss meters built in.
Okay.
So you get the color and the gloss reading together. They're completely separate readings. It's not a calculated gloss as we used to see in some. I'm sure we still see them in certain spectros, but it's a separate gloss reading with that same great performance that the standalone micro gloss meters are going to have.
Okay. Very cool. Another one, my current meter doesn't have an ASTM or doesn't meet an ASTM standard. Is that okay?
I guess it depends on whether you need to meet an ASTM spin. I mean, those things are good because it is a standard way. I mean, I guess if you're not following any sort of standard test method or not worrying about any of that when you're building a gloss meter, you might not be able to compare it with other similar meters that do meet those ASTM methods. So it's really just all about your needs and who you need to report those values to and what they're asking for. Because of course, if you're making parts for a customer, and they're saying we need it read with a 60-degree meter that meets this method, of course you need to be prepared for that with a meter that does meet those methods.
Okay, cool. Another question from Jack here. So the 20-degree spot size is limited to 1 centimeter by 1 centimeter. Currently, the opening of the micro tri-gloss is much larger. Is there a better way to block this area and measure just that 1 centimeter spot size? Or if it is blocked, does that affect calibration? Let me read that again.
No, that's okay. I'm just thinking. It might affect. It shouldn't really. If you can really just block it so that it's only showing that opening. But the thing is, you can't add anything below the meter. That sort of pads the bottom part of it, or else it's not going to be the right distance from that calibration standard, and it's not going to calibrate correctly. So I take it you have, are they exactly 1 centimeter by 1 centimeter? They don't cover the aperture?
Jack, I just unlocked your microphone. You can unmute it from your end. If you'd like to elaborate.
Hi.
Hey, welcome.
Yeah, so we often measure a lot of samples that are pretty small. And so it's kind of difficult to use the Glossmeter to measure that spot. So like it may be a centimeter, but it may actually just be a centimeter. So there's like open space on either side.
Yeah.
So we're often faced with difficulty of how do we block off that area so we can measure gloss for this smaller sample.
Okay.
So my question was just kind of like, is there a way to block this side off? Like, can we make an aperture? If I just use tape, will that affect it? That's why I kind of was asking.
So the easiest solution would be if you could just switch to the small aperture version. Is there a reason you need to measure at 20?
Well, I was just using 20 as an example. We often do all three angles based off of what our customers want. They often don't know which angle to use, so we often just use 3. 20 degrees was just an example.
Okay. Yeah, I mean it's hard to imagine a way to block off the aperture so it's exactly open, staying open on the spot where that 20-degree measurement is taking place.
Can you show him how they measure?
Unfortunately, I don't have it with me.
Not you. I'm saying Corey.
Oh, sorry.
So Corey, can you show him the angles? Yeah, because I don't know how you would do this, and I would never recommend this ever.
What do you want me to show, Ray?
So like the actual angle of the light incidence and back, I mean, it's really hard to figure out like what you should block off. Like I can't even imagine.
Yeah, I mean, especially if you're dealing with something that's exactly the spot size that you're supposed to have, it's the slightest variation of positioning could throw that off. So, yeah, that's a tough one. If you're able to send me samples that I could try, I could see what I can do. But that's really not something we can really recommend trying to block off the part of that aperture, because we just don't. It would be very, very difficult to get it exactly right.
Even with developing like a precision or precise jig?
A jig could help, certainly. Yeah, so that the relative positions of the meter and the sample are the same every time.
Okay.
That would certainly be recommended.
Okay. Yeah, we'll put Corey's email address in the chat. Feel free, Jack. We'll connect with you, and he'd be happy to do some testing on our end with one of your parts if that works for you. And any other questions that folks have out there, feel free to respond to any of the marketing emails you get regarding webinars. The recording link you're going to get, that'll either go to me or my colleague Sherry, and we'll route it to Corey or the appropriate regional sales manager there. So let me put your address in here, Corey. Jack, while we have you, any other questions or anything we can help with?
No, that was the last question. Thank you.
You're good? Okay. Thanks, sir. Anyone else have any questions? Please log them in the chat function, and we'll get to them. I did just put Corey's email address in the chat also, and it'll be at the end of the recording too that you get. And we'll go from there. Another great thing about these office hours, it's a great chance for everyone to play Stump the Corey. So so far, Jack, you got a good one going there. And can anyone beat that question? So what other, Corey, in all seriousness, what other questions or challenges that you see kind of ongoing with folks when they're getting into gloss measurement applications? Are there frequent questions you get time and time again?
That's right. So one thing I want to say is that the new glass meters work with Smart Chart, and I think that that's really beneficial. I mean, you can look at all your data over time and you can do reports. So I think that's really important. Also, the mini aperture one also works with Smart Chart. So I think that's important. Especially for automotive, because then they can take all their data and either make reports for their upper management, or they can, just use it for their own internal application.
Good point. Good point. That's one of the keys with our Smart Chart software. All of our instruments plug into it, and you can look at all the data and generate whatever reports you need from there, and collect data from suppliers. Right? If you're setting up a digital standards program, is that right, Ray?
So do that. So you could send. So say you're doing. I mean, again, I'm also automotive, and I only say it for my group. But yeah, if you're doing like inside the vehicle, you could set up tolerances for glass, and you could send out digital standards to all of your custom or your suppliers, and then they would have to match that. So there's a lot of benefits to getting the new gloss meter. I mean, I don't know, Corey, you think it's a good thing too, right?
Yeah, of course.
Cool. Quiet group here. Aside from Jack, you're excused from that comment, sir. Other questions? Anything we can help you with? And it doesn't just have to be gloss related. If you have anything on color or appearance, Corey's the guru here. So let's play Stump the Corey. Another round, shall we?
Wow, you really, really want to put me on the spot right now.
I know, and I can't think of anything to stump you with.
It's good for you.
So one other thing, like Corey was talking about the color meters that have gloss also. So if you have gloss meters and you have our Spectra 2 guide, the gloss numbers are going to match. So that's just an important thing to understand. So maybe you have out on the floor just a gloss meter, and in your lab you have the Spectra 2 guide that does color and gloss, then it's all going to match. So we work really hard to make sure that all those things work together.
Yeah, good. All right. Unless any other questions come in, I think we'll start wrapping this up. As I mentioned, you'll get an email, just an automated email from the system with a link to this recording. Feel free to share it, take it home for date night, whatever you like. Also, if you have any questions, you can hit reply to that. We'll route it to the appropriate person, or Corey's email address is in the chat there. There we go. That thing. So with that, I think we'll wrap it up. So thank you very much for joining us. We have one more office hour scheduled in December. I don't know the date offhand, but we'll make sure you get that invite a week or so before. I think it's just on just general color and appearance, physical testing, kind of more of an open forum of any questions you all have that we can help with. We're also putting together our 2022 program. We'll continue these office hours on a monthly basis, as well as sprinkle in some full presentations that we give here. Our parent company, Bitgardner Germany, they also run a monthly web seminar series. So you should be getting those emails as well. So thanks for joining us. Thanks for the conversation and discussion. And look forward to seeing you next month, where we can play Stump the Corey. Thanks, everyone. Have a great afternoon.
Thanks,
Bye.
guys.